Welcome to Are You Smarter Than an 8th Grader Science Edition. And here we have Jess and Danielle. Okay.
Round 1.
So, I want to know what a frame of reference. Okay, Danielle?
It's a point of view or perspective.
You want to argue, Jess?
I'd like to say it's the way you see something.
Okay, well, good news. You both get a point because you're both right. Yay!
Commercial time!
Jess, I need you to wake up. I really need you to wake up. I need to know what a reference point is before I wake up for school tomorrow because, I really need to know what it is. Do you know what it is?
I don't know what a reference point is.
I don't know what it is either.
Why don't we Google it? You don't know what a reference point is? Nope. I don't know either.
I don't know.
A reference point is an object that appears to stay in place. Yes, it appears to stay in place, and it's in reference to the object that you're looking at.
Does it help you determine motion or something?
Yes, that's exactly what a reference point is.
Yay, we know what a reference point is!
And this is an example of frame of reference.
One reference point is the TV. And we're back with energy.
Round 2.
Alright, I want to know with Jess and Danielle what the difference is between kinetic and potential energy. Yes, Jess?
Okay, kinetic energy is potential energy that is in motion, and potential energy is stored energy.
Very good. So you're saying kinetic energy is when an object is moving, but potential energy is when it has the potential to move.
Yes.
Guys, what even is energy?
Energy is the ability to do work.
What's work?
Work is the transfer of energy.
Okay, that makes sense.
Commercial time!
Sky, I'll tell you why if you try. The sun is going to cry, so let's start using it. Put your money to good use and let the sun do its job because it wants to help. Here's a great idea. Use solar panels. It will never run out. Sunlight is abundant. Hey, solar panels, come on and try it. The sun is crying, so use its product. Now let's move on, cause we need water. So drop the sun, cause now we're done. Let's think of water and wind. They both come from the sky, so we should try. Hey, water and wind, they are so cool. Use them wisely. You won't regret. So call us maybe.
Call 1-800-333-449.
And now we're back.
Gravitational potential energy.
It's gravitational potential energy to kinetic when I drop it.
Elastic potential energy.
So it's kinetic, then elastic potential, then kinetic when it's flung across the room. Thermal energy. Potential to kinetic to thermal. It's potential energy when it's off, then it's kinetic when you click the light on, then it's electric to get the light on, and light energy because it gives off light, and thermal energy because it gives off heat, and then it's kinetic when you shut it off again, and then it's potential because it can go back on. Chemical energy. It's potential energy, then when she chews it's kinetic, and it's chemical energy when she swallows, but also when she's chewing, it sounds. Nuclear energy. It's potential energy now, and then when my mom turns the knob, it's kinetic, and then it's nuclear energy when it lights up, Then it's heat energy, because the fire gives off heat, and it's light energy, because the blue light is shining. Then it's kinetic energy when she shuts it off, and potential so it could start again.
All about speed. Round 3.
Speed. Alright, so what's speed? Yes, Jess?
Speed is the distance traveled by an object divided by the time it takes to travel that distance.
Okay, 1 point for Jess. One more question for this round is, what's speed, what's it typically measured in? Yes, Danielle?
Meters per second.
Very good, very good. So now, Danielle has 4 and Jess has 3.
Formula for speed is distance divided by time. So, you start with the formula. Then you plug in what you know. In this case, it is 40,000 meters divided by a half an hour. Your speed equals 80,000 miles per hour.
Commercial time!
If it isn't speedy fast,
How fast is it? Velocity is the speed of an object in a particular direction.
resultant velocity is the velocity added in the same direction or subtracted in the opposite direction. Velocity equals distance divided by time. To solve an equation with velocity, you start by writing the formula. Then you fill in the numbers, which in this case is 1,260 kilometers divided by 3.5 hours, leaving the answer to be 360 kilometers an hour east because you need direction with velocity. Danielle is going in the same direction as the track, so to find her resultant velocity, you add it. Jess is moving in the opposite direction as the track, so to find her resultant velocity, you subtract them. Acceleration is the rate at which velocity changes over time. An object accelerates if its speed, direction, or both change. Acceleration is final velocity minus initial velocity divided by final time minus initial time. Lexi goes from walking to running, so she has acceleration.
How could I define gravity? The force of attraction between objects. Terminal velocity. When an object's velocity becomes constant, centripetal force is an unbalanced force that moves in a circular path. It's free fall when gravity is pulling on it and no other forces. It's free fall, yeah, it's free fall. It's air resistance, the force that opposes motion through the air. It's air resistance, word.
Friction!
Static friction.
Kinetic friction.
Bloopers!
What? What's a frame of reference?
There's someone under the bed.
What's a frame of reference?
I don't know.
I can't.
Jess? Wake up, girl. Wake up.
Darling, there's ain't no mountain high enough. Ain't no valley low enough. Ain't no river wide
Lexi, I got that eye horn thing that you had, the red one.
Yeah, Emma, you rock, Em. 4, 3.
Wait, I need my buzzer.
Just kidding!